Have you ever thought about this? The closest humanity has ever come to extinction wasn't because of nuclear war or an asteroid or an alien invasion. It was because of a hole we couldn't see, couldn't touch, couldn't hear, but one that almost burned the world alive. Yes, the ozone hole. The moment Earth's protective shield cracked open and we almost didn't make it. In the 1980s, scientists discovered a terrifying phenomenon above Antarctica, a massive gap in the ozone layer. It wasn't black, it didn't swirl like a storm, it was silent, invisible, and infinitely more dangerous. That hole let the sun's ultraviolet rays, radiation powerful enough to destroy DNA, pierce straight through the atmosphere and slam into the Earth's surface. Without ozone, sunlight stops being life-giving. It becomes death incarnate. Those rays can mutate genes, cause skin cancer, blind animals, burn plants to ash, and sterilize the oceans. If that hole had whitened just a little more, life on Earth as we know it would have ended. We like to say humanity was lucky. No, we were almost extinct. Now, let's talk about what the shield actually is. The ozone layer is a thin film of O3 gas floating 15 to 30 kilometers above Earth. It's fragile and thinner than paper, but it's the only firewall between us and the sun's killing light. Ultraviolet comes in three types: UVA, UVB, and UVC. UVC is lethal and tears DNA apart. UVB causes cancer, immune suppression, and cataract. UVA is weaker but still harmful with long exposure. The ozone layer blocks almost all of the UVC, most of the UVB, and leaves us just enough sunlight to survive. But when that shield thins, those rays flood in like predators through a broken cage. At the height of the ozone hole, ultraviolet radiation over Antarctica was 6 times higher than normal. Penguins developed skin lesions and blindness. Floating algae, the base of the Antarctic food chain, died en masse, wiping out krill populations. With no krill, fish declined, seals starved, and whales fled north. Meanwhile, in Australia, skin cancer rates skyrocketed to the highest on Earth. Crops wilted under the sun, pastures turned yellow, even plastic roofs cracked under the radiation. Scientists describe the sunlight as lethal. 10 minutes outdoors could burn you like fire. People thought it was a regional issue, a local anomaly. They had no idea it was the planet's death alarm. Because ozone doesn't just block UV, it makes life possible. Without it, the first microbes could never have left the oceans. Without it, the continents would still be barren deserts of fire. It is, quite literally, the last shield between life and cosmic annihilation, and we almost destroyed it. Do you know what caused all this? It wasn't aliens, it wasn't an asteroid, it wasn't nuclear war. It was something we invented: Freon. It sounded harmless, colorless, odorless, non-toxic, non-flammable, the perfect chemical, and that perfection was exactly what made it so deadly. In the early 20th century, cooling was the dream of progress. Refrigerators, air conditioners, aerosol sprays, symbols of modern comfort. But the old refrigerants like ammonia and sulfur dioxide were lethal. One leak and you were dead. Then came 1928. An American chemist named Thomas Midgley Jr. changed history. He created Freon, safe, stable, miraculous. At his press conference, he even inhaled Freon and blew out a candle to prove its safety. People cheered. No one realized that single breath nearly doomed humanity. Freon was so stable it could float in the air for decades, never dissolving, never breaking down. The wind carried it higher and higher until it reached the stratosphere, home of the ozone layer. And there, under the brutal sunlight, Freon finally cracked. When UV light hit it, it released a weapon: chlorine atoms. Those atoms were assassins. They attacked ozone molecules relentlessly, splitting them apart one by one, and each chlorine atom survived to kill again. One could destroy over 100,000 ozone molecules before fading away. By the 1970s, Humans were producing millions of tons of Freon every year. Every spray can, every refrigerator, every air conditioner, launching invisible missiles skyward. No explosion, no fire, no sound, just quiet, patient annihilation. In 1973, two scientists, Mario Molina from Mexico and his mentor Frank Rowland, noticed something strange. Freon wouldn't decompose no matter what they did. They proposed a radical theory. Maybe Freon wasn't disappearing, maybe it was rising, and maybe, up in the ozone layer, it was releasing chlorine atoms that were tearing Earth's shield apart. They published their findings in Nature and called for global attention, but no one listened. Chemical companies mocked them. Freon heavier than air, it can't rise. Governments ignored them, the media shrugged. Only the two of them understood. This wasn't just pollution, it was extinction. They kept working. For 3 years, they launched balloons, collected air samples, analyzed data, and then the proof hit. Freon residues and chlorine radicals were indeed in the stratosphere. Their report said it bluntly: humans are destroying the Earth's protective shield. The so-called perfect chemical, once a symbol of progress, was actually a planetary poison. Scientists later calculated that if the problem had been discovered just 10 years later, the Antarctic ozone layer might have collapsed entirely. UV radiation would have reached the equator. Human skin could not survive 1 minute of direct sunlight. Crops would have died. Plankton, the base of the ocean food chain, would have burned away. Oxygen cycles would have broken down. Ecosystems would have collapsed. It wouldn't have been global warming, it would have been global burning. And the scariest part, we were doing it ourselves. One spray, one breath, one refrigerator at a time. Things became truly terrifying in 1985. That year, a British Antarctic research station made one of the most shocking discoveries in scientific history. The ozone layer above Antarctica was gone. Not thinning, not decreased. Gone. At first, even the researchers didn't believe it. They assumed their instruments were broken. But after checking and double checking and comparing with past records, the truth was undeniable. There was a hole, a real gaping hole in the sky. When the sun rose over Antarctica that spring, it unleashed ultraviolet radiation with no filter, no barrier, no mercy. Scientists reported that the UV levels were so high you could get sunburned in under 5 minutes. Some estimates showed UV readings 6 times higher than normal. Penguins began going blind. They developed open sores on their skin. Phytoplankton, the base of the ocean's food chain, died off en masse. The entire Antarctic ecosystem began to collapse before our eyes. Meanwhile, at NASA, they frantically searched for satellite archives and made an even more horrifying realization. They'd already seen the hole, but their computers had discarded the data thinking it was an error. It was too low to be real. It's as if humanity had been shot in the head, and our sensors just shrugged and said, "That can't be right." Then came the word that changed everything: ozone hole. That phrase made the danger real. Suddenly, people everywhere realized this wasn't just some academic theory, it was above our heads. In Australia, people got sunburned in minutes. In New Zealand, crops shriveled. In Antarctica, researchers had to wear full bodysuits just to go outside. Plastic roofs cracked from under the sun. And the worst part, the hole came back every year. It was seasonal, like some cosmic executioner returning every spring. At its peak, the hole reached 30 million square kilometers, about the size of North America. During that time, global skin cancer rates soared over 20%. Eye clinics were overwhelmed with cataract cases. Agriculture departments issued hundreds of UV warnings. Plastic manufacturers had to redesign materials. But those were just the visible effects. In the ocean, the death of plankton led to a krill collapse, which starved whales. On land, UV destroyed chlorophyll, slashing crop yield and damaging the carbon cycle. Coral reefs stopped reproducing, bleaching, dying, vanishing. Scientists warned a 10% drop in ozone could lead to 25% less food worldwide. In other words, we wouldn't just burn, we'd starve. And all of this actually happened. In just a few short years, before we even fully realized what we'd done. It was the first time humanity looked up and saw its own extinction reflected back from the sky. A lot of people think the ozone hole story is over. We signed the treaty, we banned Freon, the world came together, problem solved, right? Wrong. This crisis is far from over. After the Montreal Protocol was signed in 1987, humanity did something extraordinary. We stopped producing the very chemicals that made our lives easier, but we misunderstood one thing. We had created a time-delayed weapon. Freon doesn't kill instantly. It floats, it lingers, it climbs on up, and eventually, it takes decades to rise into the stratosphere. Even if we stopped using it in 1987, the Freon released in the 1950s, 60s, and 70s is still drifting upward, like a ghost that hasn't reached its haunting place yet. So no, we didn't put out the fire, we buried a ticking time bomb in the sky. The ozone layer hasn't healed, it's still bleeding, just slowly. Even worse, the hole isn't shrinking in a straight line. Some years it grows again. In 2020 and 2023, scientists observed the ozone hole above Antarctica expanding to levels not seen in decades. UV radiation levels surged, the wound reopened. The World Meteorological Organization said it clearly. We are not safe yet. Why does this happen? Two deadly ingredients, cold and sunlight. Freon's destructive chlorine atoms are released when exposed to strong UV light, but this reaction thrives in extremely low temperatures. And where do we find both sunlight and extreme cold? Antarctica, the coldest, brightest place on Earth. Every September, as polar spring begins, the sun returns to Antarctica. Cold air plus UV rays equal a massacre. It's like Freon lies dormant in the ice, waiting for the sun to trigger its attack. Each year, the hole opens like a scar, bleeding radiation onto the Earth. And we just watch it happen again and again and again and again. People say it's fine, just give it time, it'll heal, but scientists say otherwise. True recovery may not happen until 2066. From discovery to full healing, that's almost 80 years. One chemical damaged Earth's shield for an entire human lifetime. And now, the bigger question looms. Is Freon the only threat? New studies suggest that certain industrial solvents, next-gen refrigerants, and even some ozone-friendly alternatives might still be causing micro-level damage. Worse, climate change itself might be slowing down the recovery. As temperatures rise, the atmosphere's delicate balance is thrown off. Restoration becomes harder, slower, maybe even impossible. The brutal truth? We think we fixed it, but one day the sky might break open again. We barely survived the sun once. Next time, we might not. One might think, if we solve the ozone crisis once, doesn't that mean humanity can rise to the occasion when faced with existential threats? Maybe we'll solve global warming the same way. If that's what you're hoping for, I've got some bad news. The ozone treaty success actually shows just how badly we're failing now. The Montreal Protocol is often called the most successful environmental agreement in human history, not just because it worked, but because it was fast, decisive, and global. From discovery to international action took just 2 years. Now imagine telling the whole world today, you have 2 years to stop using oil, gas, and coal. You really think that's gonna happen? Because let's be honest, the ozone success was a lucky break. We had replacements for Freon. Its uses were limited, mostly in refrigeration and aerosol sprays. Big companies didn't fight too hard. Some even profited from the transition. And most importantly, people didn't need Freon to survive. But the climate crisis? It's built into everything. How we eat, drive, build, ship, heat, light. All of it runs on carbon. To fight global warming means reshaping the very core of modern civilization. And worst of all, the ozone threat hit hard and fast. You could see the hole, measure the cancer spike, film the penguins going blind. But climate change? It's slow. So slow it feels unreal. There's no hole, just a steadily rising thermometer. No sudden burns, just more floods, more droughts, more deadly heat waves. No instant cancer, just melting glaciers and record-breaking years. It's a crisis that's too boring to fear. It doesn't scream, it whispers, and we ignore it. Ironically, we understand today's threat better than we did back then, but we're acting worse. One scientist said it best: the Ozone Treaty was our environmental moon landing, a moment of unity and triumph. Now, it's just a lonely success in a sea of failures. After its implementation, CFC levels in the atmosphere began to fall. The infamous ozone hole over Antarctica, once bigger than the continental US, started to shrink. NASA reports estimate that if we hadn't taken action, by 2065, the ozone over mid-latitude regions could have dropped by 67%. At that point, even wearing SPF 1000 wouldn't have saved us from skin cancer and genetic mutations. So yes, we dodged the bullet. We genuinely stood at the edge of real-world apocalypse, and this time, global collaboration pulled us back. But what about the next time? Climate change, carbon emissions, microplastics, AI risk. Can we really pull off this kind of unity again? Do we have the capability and the will to act? Or has our luck already run out? Thank you very much for watching today's video. If you liked the video, please remember to subscribe to the channel, give us a like, and leave us a comment about your thoughts about the ozone hole and other environmental mysteries that we've got going on. Thank you very much for watching again. Have a great day.